Hi and welcome to Module 4 of the EVP Certification Review course. This section is Analysis and Management Reports. So this is really where the rubber hits the road in earned value management. It's about preparation of reports, which is a key aspect of communication with stakeholders, and interpretation of those reports so that the right actions can be taken. So the objectives of this section are to review and understand execution of work and implementation of earned value management, schedule performance metrics and how to understand and interpret them, cost performance metrics and how to understand and interpret them, the definition of estimate at complete, or EAC as it's referred to, and some of the techniques that can be used to come up with statistical forecasts, or I guess guiding sort of arithmetic that you can use just to check and get validation that your EAC that you've come up with is adequate. So the EVP body of knowledge diagram for analysis and management reports covers progress reporting, variance reporting, customer reporting submittals, risk mitigation, managerial analysis, estimate at completion and estimate to completion, and a little bit about subcontract management as well. So firstly, analysis and management reports, it's really important to keep in mind that it should be a forward-looking approach to cost control. So it should provide timely visibility into the scope, schedule and cost process for both internal and external analysis and reporting. So it generates planning and performance data at the appropriate level to be used by management in the decision-making process. So what that means is you've got various different stakeholders who'll have all sorts of different information needs. It's really important to have an awareness of what their information needs are, so that reports can actually be tailored to suit the information that different stakeholders need to see. Analysis and management reports provide a sound basis for projecting the final performance costs and performance requirements. So the idea is that the purpose of these reports is, yes, to look into the history and understand what problems there have been, but the main purpose being to improve the final outcomes of the project and to apply that knowledge and information to help make the project successful for the remaining duration. The analysis and management reports also provide meaningful performance indicators to provide early warnings of potential problems as well. So execution of work using earned value methods. Firstly, there's the organisation and definition of the project, which we've already covered. It's basically the statement of work, the WBS structure, the OBS structure, the assignment of different organisational elements to that work breakdown structure, and having a work authorisation process. We've spoken about developing the performance measurement baseline, so considering schedule, risk analysis and the risk management plan, taking in the resources from the estimate, resource planning, time phasing that budget, and then applying earned value techniques for the different work packages that you're envisaging. Then the next step really is about implementation and measuring performance. And this is execution of the work, monitoring the integrated cost and schedule baseline, determining earned value or the amount of progress that's been made, collecting actual costs, and then comparing and creating meaningful metrics from the amount of progress that's been made and the actual costs to date. Analysis and analysis of the data and reporting is all about variance analysis, so actually quantifying some of those differences, picking up different trends and patterns and providing early warnings of them, and using that information to develop estimates at complete. So there's a lot of different terminology that's used in earned value management. Particularly there's a lot of sort of old-fashioned technology that's probably a little bit onerous. So for the purposes of this presentation, if you've ever heard of some of the old terminology such as budgeted cost of work scheduled, budgeted cost of work schedule for the purposes of this presentation has been replaced by the term planned value, which I think is a lot more meaningful and tends to make a lot more sense. Budgeted cost of work performed, as it used to be called, is going to be referred to as earned value, and actual cost of performed will just be referred to as actual costs. So I guess the key points for review, or the key points to understand as the basis for some of these terms. Planned value is basically the sum of the budgets for the discrete scheduled work accomplished, plus the appropriate portion of the budget for the LOE packages in the relevant time period. This is essentially the baseline for performance measurement, or the PMB. The earned value is essentially it's the same thing, except this is the amount of progress that has been made. So it's the sum of the budgets for the completed portion of the in-progress discrete work, plus the appropriate portion of the budget for the apportioned and LOE work in that same time period. And the earned value is determined using the most appropriate progress method as always. Whereas the actual costs are the total costs incurred in accomplishing the work in a given period, and the actual value is based on the cost captured and the hours recorded. The budget at completion is basically the cumulative value of the planned value over the duration of the project. So it's the overall budget essentially. It's the cumulative value of the performance measurement baseline, or PMB. The estimate to complete is basically just the estimate of the resources and costs required to complete the project. And it's used, if you add that ETC to the actual cost to date, you come up with the estimate at completion. Work progress measurement is basically objective measurements to determine the work performed. It's measured by earned value methods and techniques. So this diagram it looks quite complicated, but it's actually fairly simple, showing execution of work, or the actual process for developing the earned value metrics. As you can see, starting off, I guess, looking at, or making it a little bit more simple, if you look at the planned value, in other words, the performance measurement baseline, then you have the EV, which is basically a very simple calculation of physical percent complete based on those earned value methods that you've adopted. And then the financial accounting data, which collects the actual costs using those accrual processes that we spoke about in the last module. Once you have those three pieces of information, those three simple pieces of information, planned value, earned value, and actual costs, you're able to calculate schedule variances, cost variances, percentage relation, and these can be expressed as either ordinary values, or they can also be expressed as percentages, or even ratios or performance indices such as SPI, CPI, and forecasts as well. So once you have that data, you can slice and dice it, and it's all very simple arithmetic. It just depends on how it's being presented for which particular customer. So from that, you take that information, you generate initial reports, and you share that with the different stakeholders, so typically project managers, control account managers, review and analyse, do a sense check, look for variances and come up with the explanation for the variances, the root causes and the mitigation steps that are going to be used. If necessary, adjust your estimate to complete for your remaining work, and then basically produce reports and share them with your stakeholders. So that's the typical cycle, and that's the cycle that will happen within each reporting period in an earned value management system. So some of the performance measure metrics that are typically used. So for variance calculations, it's typically about schedule variance and cost variance, but there's also a measure of variance at completion as well. Now those variances can also be expressed as a percentage, so you can have schedule variance and cost variance as a percentage. You can also describe the overall work performed as a percent complete, as a percent scheduled, and a percent spent as well. Expressing those same factors as indices or ratios, you have a schedule performance index, a cost performance index, and a to complete performance index. So the main important thing to take away from this is that you can express the performance in a number of different ways, and it's important to be sensitive to your stakeholders to understand what their preferences are, and it's very easy to adjust the presentation of that information to suit your stakeholders. So the other thing about these variance calculations is that you can set them up so that they're either sensitive to the current period, or they can be over a longer duration, typically the cumulative to date, or you might even select a window, say a 6-month window, if you want to have a look at different patterns or performance characteristics. The ones that are typically used are the current period and the cumulative to date. Current period, seeing what's happening now, what are the short-term trends, whereas cumulative to date might give you an awareness of particular patterns or trends that are happening over a period of time. So schedule variance is calculated as the value of work performed less the value of work scheduled. So it's very, very simple. Basically, earned value less the planned value. A positive result means you've done more than you were planning to, so the project's going well. A negative result means for some reason you've done less work than you had planned to. Cost variance, it's a very similar principle. So this time we're comparing earned value with the actual costs. So if there's a positive result, it means that the project is experiencing an underrun, or we're achieving more earned value, we're earning more value than we are spending. A negative result means quite obviously the opposite. So the project is experiencing an overrun, and for some reason we're spending more than we're actually earning. Variance at completion is sort of projecting that out and looking at the end of the project and saying, what are we going to project at the end? Are we projecting that our overall cost is going to be over the budget or less than the budget? Once again, a positive result, meaning that the project is experiencing an underrun or spending less money than budgeted. A negative result, meaning that we're experiencing an overrun and likely to overspend. So there's a number of different ways to present information in earned value management on projects. Probably the most standard or the most common method that's used is the SCurve, as it's called, which is basically a cumulative visual or graphical representation of the planned value, the earned value and the actual cost on one graph. Now this diagram here portrays it very well, and it shows you some of the different variables and how they're calculated as well. As you can see in this particular example, the actual costs are running significantly over the earned value, and there's also a projection that the project is going to complete behind schedule as well. From this metric you can see that it's fairly easy to measure current variances, so between, for example, the cost variance and the schedule variance by looking at the gap between earned value and actual costs and the gap between earned value and planned value, but also to project that out and look at the difference between the forecast completion and the budget at completion. Looking at a little bit more detail into some of those ratios, the schedule variance is basically what percentage the schedule varies from what's been planned to date. So it's a very simple calculation. It's basically the schedule variance divided by the planned value times 100. Cost variance, very similar thing. It's the value of the cost variance divided by earned value times 100. So what percentage of our earned value has been a cost variance. The percentage of work scheduled, which should have been completed up to a particular point in time, is basically the planned value cumulatively divided by the budget at completion. And very similarly for the percentage of work performed, it's the earned value divided by the budget at completion, which tells you what percentage of the overall project you've completed. And once again, you can run a similar calculation for the money expended or actual cost to date at a point in time. It's your actual cost divided by the overall budget. A very, very simple ratio. Performance indices, it's the same thing, except this time rather than expressing as a percentage, it's basically a ratio. For schedule variance, it's basically earned value divided by the planned value. And for the CPI, it's basically earned value divided by actual costs. Okay, so having established your CPI and SPI, it's really helpful to look at your remaining work and say, okay, what sort of a CPI am I projecting that I'm going to need if I want to finish my work to the overall budget, or if we want to finish this project to the overall EAC that we're currently anticipating. So in order to come up with an idea or a forecast index that we think we're going to need, we use an index called the TCPI, or the Two Complete Performance Index. So the two Complete Performance Index can be calculated if we want to look at, or if we want to forecast the index we need to reach the budget. We basically calculate it as the remaining value or the remaining work on the project that hasn't been completed yet, divided by the remaining budget that we have available. So it's the budget at completion less the earned value that we've already achieved, divided by the overall budget at completion less the actual cost that we've already spent. And by looking at that index, we can see if it's greater than 1, we're going to need greater efficiencies than we've been anticipating in order to finish on budget. And if it's lower than 1, it means that lesser efficiencies than planned are going to be required to meet the overall budget. Now, very similarly, we can also calculate the index that we're going to need in order to achieve the EAC that we're currently forecasting. And it's the exact same calculation, except this time we look at the overall remaining work, so the budget at completion less the earned value achieved to date, and we divide that by the overall EAC less the actual cost that we've achieved to date. And once again, an index that's greater than 1 gives us an indication that the cost performance is going to, a greater cost performance index is going to be required to complete the work to the EAC, whereas less than 1 tells us that we can be less efficient. We can be performing it in a less efficient manner and still reach that EAC that we're currently forecasting. So for example, as a simple calculation or a simple example of a calculation using these sort of indices, if we have a look at this particular graph here and we calculate the schedule variance. The schedule variance is a percentage and then the schedule performance index. So the schedule variance is a very simple calculation. As we've explained, it's just the earned value less the planned value. So in this case, $40,000 less $60,000 equals negative $20,000. It's that simple. So that's telling us basically that we're 20,000 behind schedule in terms of schedule variance. The schedule variance is expressed as a percentage, is basically the schedule variance divided by the planned value, all right, times 100 to come up with that percentage. So in this case, negative 20 divided by 60 times 100 gives us negative 33%. Expressed as an index, the SPI is the earned value divided by the planned value. 40 over 60 equals 0.67. So there's three examples of the metric, all of them telling us that we have a schedule problem, but they can just be expressed in different ways depending on what your stakeholders' preferences are. So some potential causes for schedule performance, and obviously there's thousands of them, but we've listed a few typical ones here. So unfavourable schedule performance problems might be a result of manpower shortages, revisions or changes to a plan, supporting organisation behind the schedule, late vendor delivery, delayed feedback or direction from a customer, rework or work just being more complicated than anticipated, design review comments, unclear requirements, scope creep, weather. There's all sorts of things that can impact a schedule negatively, for example. And of course on the favourable side, it's almost the opposite. So you can have efficiencies being realised, work being less complex than anticipated, fewer revisions and rework required, favourable market conditions, or a subcontractor being ahead of schedule. So an earned value schedule variance is basically stated in terms of dollars, and it's really important to analyse schedule variances in conjunction with other information such as critical path networks and some of those sorts of things. By itself, earned value schedule variances do not reveal the critical path. So information can be misleading because unfavourable accomplishments in some area can be offset by favourable accomplishments in others. So what this is basically telling us is that earned value measures how much work has been done compared to the plan, and the schedule variance tells us how much or what the difference is between the work that's been achieved and the plan, but it doesn't tell us whether the right work was being worked on. So for example, you could potentially be achieving a lot of work and being ahead of plan, but not addressing activities that are on the critical path, for example. So this is one of the limitations of schedule variances in earned value. So it's really, really important to also be analysing total float and keeping an eye on the right work fronts, and make sure that the work that's closer to the critical path or closer to critical interfaces is being progressed more so than work that might have a lot of total float available. Okay, so moving now on to cost metrics, which are very similar in principle to the schedule metrics that we've already looked at. So once again, for this very simple example, we're going to have a look at an example calculation of cost variance. Cost variance as a percentage, and cost or CPI, or cost expressed as an index. Once again, very simple. So the cost variance is the earned value less the actual costs to achieve that earned value. So in this case, we have an earned value of roughly 40,000 K less actual costs of roughly 50,000 K gives us negative 10,000 K. Negative straight away tells us that this is a cost overrun situation. Expressed as a percentage, it's once again it's just that cost variance, negative 10,000 K divided by the 40,000 K times 100, giving us negative 25%. And it can also be expressed as a CPI, so earned value less divided by the actual costs, 40 over 50 giving us 0.8. So both of those, or the cost variance being negative is telling us that we have a cost problem. The cost variance as a percentage is negative, telling us we have a cost problem. And the CPI expressed as a ratio is less than 1, once again giving us that indication that we have a cost efficiency problem. Once again, a wide number of potential causes of favourable and unfavourable cost variances. We've listed some of them here. Work being unfavourable causes are work being more complex than anticipated, extensive design review requirements, rework, unclear scope creep, unfavourable market, overhead rate increases, for example. And favourable on the positive side, efficiencies being realised, work being less complex, fewer revisions and rework, favourable market fluctuations, and a decrease in overhead rates. And there's plenty others, I'm sure you could think of plenty of other sources of favourable and unfavourable cost variances. Okay, looking at these percentage relationships for the same earned value data, and this time expressing the overall progress as a percent scheduled, a percent complete, and a percent spent as another way to represent the progress on the project. So the percent scheduled is basically the planned value to date divided by the overall budget times 100. So in this case we have the overall planned value of 60 divided by the overall budget of 100, giving us 60% complete. So we had planned to complete 60% of the project. The percent completed is the earned value divided by the budget at complete, which in this case is 40,000 divided by 100, giving us 40% complete. And the percentage spent, in this case we look at the actual costs, so we have $50,000 divided by $100,000, giving us 50% complete. So this just gives us that overall percentage of the work that was planned, the work that has been completed, and the actual cost of that work. The two complete performance index, all right, which is the index that we spoke on a little bit earlier. To calculate, or the goal here is to calculate the performance factor, or the TCPI, that must be achieved on the remaining work in order to stay within the budget at completion goal set within the PMB. So once again, the TCPI based on the budget is the remaining work divided by the remaining budget, or the budget less the actual cost to date. So for this calculation, the remaining budget is 100, right? The overall budget less 40, which is the earned value that we've achieved so far, giving us 60,000 K remaining. And the remaining budget, or the budget less the actual cost to date, is 100 less 50, giving us 50, gives us a TCPI of 1.2. So what this is telling us is we're going to need to perform at 1.2. So we're going to need to be highly efficient if we want to complete this project in alignment with the overall budget. Now, to represent it on a graph is really helpful because it helps us show, it just helps us give that visual representation of is that expectation realistic? Can we really expect for our performance index to be 1.2 for the remainder of the project? So this diagram here, we basically have that cost performance index on the y-axis, and we can see the history of how we've been performing to date. We have time now represented by the dotted line on the slide at July, and then we can see the TCPI where we're forecasting that we're modelling the expectation that we're going to perform at 1.2 for the remainder of the project. So as you can see, based on past history on the project to date, it does seem quite unlikely. So by producing metrics like that, it makes it easier to bring up that conversation and help get some more reality into the overall plan and improve the forecast or the estimate at completion. Okay, so it's fairly clear we're not likely to reach the overall budget. Let's have a look at the estimate at completion and see how realistic our plans might be towards achieving that. And let's say, for argument's sake, that the estimate at completion on this project is 115,000 K. So the TCPI with respect to the EAC is the budget at completion less the earned value that we've achieved to date, so the remaining work, once again 100 less 40, and it's the estimate at completion less the actual cost to date. So it's 115,000 K less 50 K, giving us a ratio of 0.92. So what that's telling us is that we're going to need to perform at a performance index of about 0.92 if we want to finish this job and have actual costs at $115,000. So once again, looking at that metric, which just provides that visual representation and that sanity check on how we've been performing to date versus what we're anticipating that we're going to perform at. This one seems a little bit more realistic, where we can see the CPI to date has sort of bubbled around somewhere between 0.8 and 1, and we're forecasting, or we're saying that if we're realistic in our expectation to reach 115K for our EAC, from now on we're going to need to be performing at a CPI of 0.92. And so you can see it does seem a little bit optimistic, but it certainly looks a lot more realistic than any sort of expectation to finish on budget. So these type of things can be really helpful to provide that sense check and to provide a visual representation that can help that discussion process with stakeholders. So the estimate at completion, just for clarity, that we've been talking about is basically the forecast for completing the total project, considering the performance to date, plus the estimated, plus future estimated cost to completion. So the EAC equals actual costs plus our ETC, or our estimate to complete. Formal EACs, which are often run on larger projects, cover the full period of the project. They represent a complete review of the plan against the project with appropriate revisions. They consist of the actual cost to date plus the EAC. They tend to be performed bottoms up, so at the work package and planning package level of the control account. It includes a review of the remaining scope and the schedule for completion of work, and a re-evaluation of the risks, the usage of MR and contingency. So a formal EAC is basically a bottoms-up approach of looking at all of the remaining work and rolling up those estimates of resources and costs. It includes all approved changes since the last EAC and takes into account selected identified or early warning issues or performance issues that might have been identified. It incorporates the latest rates for labour costing, for example, any subcontractor surcharges and overhead costs. It includes a complete re-evaluation of project risks, including technical schedule and cost contingency, and it should be conducted at least annually. Depending on the duration of the project, you might even do it monthly or quarterly. Now the statistical sort of forecast that we can use with EACs should never be a replacement for a formal bottoms-up EAC, but there's some statistical techniques that you can use just to do a reasonableness check test, or a sense check, if you like, of how valid or how credible the numbers seem to be from your bottoms-up process. The three determining variables for your EAC are the total of your actual cost to date, the value of work remaining for incomplete tasks, which is basically your budget at completion less the earned value for the work that you've already completed, division of the remaining work by some performance or efficiency factor. So the whole idea with the statistical forecasting is you look at the remaining work, you look at your efficiency or your CPI for the work you've been performing to date, and then you project that to some extent for the remaining work and you see what the numbers look like. So you can come up with a range of EACs depending on your desired confidence level, or how confident you want to be that you've got enough contingency and enough allowance to finish the job. And you can justify a project manager's EAC if it's lower than a straight line EAC. So an EAC basically equals your actual costs plus your your statistical EAC equals your actual cost to date plus your remaining work divided by the CPI that you've been achieving so far. So by dividing it by the CPI, you're applying that performance factor to the remaining work and then projecting that out for the remainder of the work. So essentially you're assuming future work will be performed at the same CPI as the work you've done to date. That's the most commonly used method. More accurate approaches can be used by applying specific CPI factors for discrete work, different work fronts, craft labour and different teams, etc. So you can become more sophisticated with it if you know there's some causes of CPI problems or performance problems that have been in the past that don't exist anymore. You can filter those out of some of your factoring and calculations, and you can project out based on the type of work that you've got in front of you as well. So the advantages of statistical EACs is that they can be automated. They're often based on historical data. The detail level EACs are they can be very easily summarised, and they can be tailored to suit the performance or the anticipated performance of a project. Some of the disadvantages are that some of these models don't take into account things such as critical path and some of the effects that critical path issues can have on cost and some of those sorts of things. And they often don't consider resource loading requirements and limitations. So it does tend to simplify things when you're using the statistical process. That's why it's really important to keep in mind that it really is should be used as a validation process for your bottoms-up EAC process. So statistical EACs should not be the final EACs. Statistical EACs can be used as a tool for performing checking of EACs and performing comparative analysis to verify the credibility of EACs that are derived from first principles. So the key summary is that, I guess, the key definitions are the three ingredients that we use for earned value are the planned value, the earned value and the actual costs. Overall, we have the budget at completion, and then we have the estimate at completion, which is our forecast, and then we have a work progress measurement process that we use for measuring progress as we're going along. We have a number of different performance metrics that we use for understanding how the project's performing and communicating with different stakeholders. And it's important to understand the estimate at completion. It can be done using a formal process or a bottoms-up process for all of the remaining work, as well as using some statistical techniques based on the performance to date, just to do that sense checking and credibility checking of the EAC that we've done using a formal process. So in summary of the performance metrics, the variance calculations, we have schedule variances, we have cost variances for performance to date, and then projecting outwards we have a variance at completion, which is telling us the forecast variance compared to the PMB at completion of the project. These can be expressed as percentage relationships as well, so we have a schedule variance percentage, a cost variance percentage, percent complete, percent scheduled and percent spent. And of course performance indices and factors, which once again is just taking that same information and expressing it as a schedule performance index, a cost performance index or a to complete performance index. Now risk assessment and mitigation. So we spoke about risk assessment a little bit earlier on when we were talking about planning and budgeting. During execution and tracking performance, it's really important to stay on top of risk management as well, because it's just so common that the things that are driving risks the risks that are being identified on the project and managed on the project are very often the same things that are driving or the root causes of performance problems on a project as well. So risk management is concerned with the outcome of potential future events whose results are uncertain and the development of strategies to deal with these uncertainties. So with all of our performance problems, the first thing that we do is we say, okay, what was the root cause of this problem and what are we going to do about it? So what are the strategies and the mitigation steps? So it's very, very similar, performance management and risk management. So risk management is the art and science of handling that uncertainty for future events to help enable a favourable outcome. Very similar once again to what we're doing with performance measurement. So we're looking at the effects that have happened to date and trying to use that information to forecast what's going to happen in the future. Often the risks identified in the risk management process become contributors to the performance issues that are identified in the earned value system. So risk management is the practice of dealing with and assessing and mitigating risks. So it includes planning for the risk, analysing the risk, developing risk mitigation options, continuously monitoring the risk, documenting the overall risk management process, and the development of strategies to deal with uncertainty. So the assessment of these project risks should be considered when building contingency into the PMB, as we've discussed earlier, but also for our ongoing forecasts as well. So and just a reminder that the risk management and mitigation process was discussed in more detail in the planning, scheduling and budgeting module, but it's really important to recognise that risk management process, it doesn't just happen at the start of the project, it happens during execution of the project as well. And so as an earned value professional, you really want to be really closely involved in that risk management process as well. So the next section we're moving on to is variance analysis and reporting. And it's really important to understand from this section the actual process that we use for performance reporting and analysis, variance analysis itself, contract performance reports or CPRs, which are a typical type of performance report that's produced by earned value metrics, and some examples of performance metrics. So EVM analysis and reporting is crucial, basically. So it's taking all of the information, the performance information, and turning it into something meaningful that can be shared with different stakeholders to help make the project successful. Proper analysis of the reports helps enable appropriate actions to be taken, and it's also helpful for the identification of problems that would otherwise not be picked up. So once again, this is going back to that overall flow chart, right? So now we've taken the inputs, the planned value, the earned value, the actual costs. We've put them into the cost processor or the earned value metric machine, if you like. And so now the idea is to take that information and project it outwards and to share that with different stakeholders in the interests of helping improve the performance of the project and recovery planning as it's needed. So what is a variance? A variance is a quantifiable deviation or departure or divergence away from the known baseline or expected value. So a cost variance is a measure of the cost performance on the project, and a schedule variance gives us a measure of the schedule performance on a project. So I guess the purpose of earned value is to find significant variances or variances that matter. So we may tend to ignore those that are occurring at the start of a project. So it's fairly common when you first set your baseline and you start work on the project that the data might be a little bit messy and there might be some spikes that aren't particularly meaningful. But the point is to quickly identify those and make sure it's the variances that matter that are getting the attention of management. So by identifying variances, it also helps us to graph and analyse trends and patterns in performance and look at comparative data. So we can compare cumulative performance versus the projected performance and say, okay, is that realistic for us to be projecting that type of performance? And we can also compare current performance versus cumulative. Okay, so we went particularly well this month compared to the past. Why is that? And understanding that and helping that to drive future decisions. And it's about examining written analysis as well. So when we do identify a variance or a performance problem or something that's going particularly well, it's really important to understand why. What is the root cause that's happening there? And what are we actually going to do about it? Is correction action required? And what are those steps that we're taking? And to be in the habit of systematically analysing that and asking those questions and documenting it is a really healthy process for the project. Now, of course, in parallel with that, we also want to be analysing schedule trends and monitoring total float. So that's the one blind spot for earned value metrics alone, is that we're not tracking total float. So if you make that part of the package so that you're analysing your earned value metrics and in parallel with that also analysing total float, it helps make sure that you're covering all areas. So some of the types of variances that you can have, so values can be expressed as either current period or cumulative to date. So current trends tend to be more volatile, so your earned value data for the current period will tend to be up and down quite a bit, whereas the cumulative data to date tends to be a lot more stable and tends to show long-term trends. Just as an easy rule of thumb, as we've already mentioned, negative values for variance are unfavourable, positive values are favourable. And when we're talking about indexes such as SPI and CPI, less than 1 is unfavourable, where greater than 1 is favourable. So the absolute variances can be expressed in terms of dollars or hours or even quantities, depending on what units you're using or what stakeholders you're preparing reports for. But they may not tell us the significance, they may not be able to tell the significance from the amount. So depending on the size of the work package, different absolute values could be significant or not. That's why sometimes it's helpful to express it as a percentage as well. So it basically expresses the absolute variance compared to the overall value for a particular work package or project, and it helps show the significance relative to the overall value. Whereas an index is another way of expressing it. It basically compares one value to another in a simple ratio. So if you're on plan or you're on track or you're on budget, it's 1. Greater than 1, you're performing well. Less than 1, you're performing below budget. So the variance analysis checklist. So the idea with variance analysis is that once you've identified, once you've identified a significant variance, you want to understand the cause of the variance and the root cause of the variance. So you should be asking yourself questions such as, have I explained and quantified errors in the data? So have you checked the data for validity? Have I explained and quantified distortion due to any earned value technique? So if you're using an earned value technique that's not quite perfect, to be able to understand that and rule that out of the equation. Have I identified and quantified significant labour rate variances, for example, or changes in rates? Or have I provided a clear and concise explanation of the reason for the variances? Having understood the root cause, it's then about the impact of the variance. So have I considered the impact of the critical path and non-critical path activities? Have I considered the impact on other control accounts? Is the explanation specific and does it include dates and or durations? And have I considered the impact on the EAC or our forecast costs? So we don't just consider the flow on impact, we also consider corrective actions that need to be taken as well. Are the correction actions specific? Have I included who, what, where and when? Have I considered my estimates of future performance? So the flow on effect. The estimate at completion. So if I have a significant cost variance, for example, have I re-examined my EAC and increased the EAC to allow for that increase in costs? Have I justified why the EAC should be changed, or why it doesn't need to be changed if it doesn't need to? Does the corrective action support my EAC analysis? So if I'm taking all these corrective actions, have I accommodated costs within my EAC for those actions? And then the last thing is getting that endorsement, depending on the company processes and procedures. Has it been signed off, or has it been authorised by the control account manager or the responsible manager for that work? So cost performance reporting. So there's a cost performance report which provides project variances and metrics. That's a fairly standard format of report. So it provides current period data, typically for the current month, and cumulative to date. And it also provides at completion data for the forecast at completion versus the budget at completion. It's usually prepared monthly by the project controls team and reviewed by project management. And the report format is typically available electronically from a number of different tools and can often be done in Excel as well. So the CPR format, there's typically 5 different formats that are used, and these are particularly tend to be used on defence contracts, for example. Format 1 is based on work breakdown structure. Format 2 is based on organisational breakdown structure or an organisation cross-cut. So the earned value data is summarised by OBS rather than WBS. Format 3 is a baseline reconciliation. So this is all about change control and tracking changes. Format number 4 is a staffing forecast. Format number 5 is your variance explanations and problem analysis. So there's a reference there, DI-MGMT 81466A, for descriptions or more detailed descriptions of those standard reports. So in typical CPR reports, the financial data is usually shown in thousands or summarised in thousands of dollars. And data is expressed in direct dollars and subtotaled in direct dollars. Overheads are normally shown as a separate line below the direct line. Baseline and performance data supports the status reflected in the project schedules, so it should be based on the same progress information from the schedules. And the current month actual costs should align with and tie into the accounting general ledger for the current month. Cumulative actual costs should reconcile every month. So here's an example of what a typical cost performance report looks like. This one's organised by WBS. So as you can see, there's 3 sections: the current period, the cumulative to date, and then the at completion. So the first period, the current period, is looking at the current month to date and looking at the planned value, earned value, actual costs, cost variances, and then SPI and CPI. The cumulative to date is looking at the exact same variables, except it's looking at the trend or the performance over the cumulative to date on the project up till time now. And then the at completion is looking at the overall forecast for the project budget versus the estimate at completion. You can see that there on this one there's a bit of conditional formatting that just basically is highlighting any areas where the SPI or the CPI might be performing badly, are highlighted in red. So it's fairly common to use a bit of conditional formatting and some of those sorts of things to enhance this management by exception concept. Another example of that tends to be more commonly used on engineering construction projects is the SCurve, which is a really handy one for senior management, just to provide that very high level summary of how a project's performing without having a lot of the detail analysis. So the typical presentation would be at SCurve level, and if there are problems that are identified, people can very easily drill down into the CPR report that we were just looking at to understand exact specific areas where there might be cost problems or schedule problems. So once again, looking at this graph, we've got a representation of the budget at completion, right, or the planned value with the black line. The actual costs are represented by the red line, with the forecasts being shown in with the dotted red line, and the earned value being shown by the green line. And from there, looking at the time now, the dotted line in the page, from there we can calculate our metrics to date. We can look at our cost variances and our schedule variance, and we can also see that looking or forecasting out, we can see the variance at completion as the difference between our EAC and our budget at completion. We can also see the forecast project slip, looking at the timeline between the completion of the project and our budget, the forecast completion date based on our budget at completion. This is another very handy metric that is quite commonly used on projects. It's a tracking of the CPI and SPI. So once again, when we're looking at indexes, 1 is basically an indicator that you're performing on plan. So it's really easy to have a representation of your cost and your schedule performance on the same page. And for this particular project, you can see the trend, for example, with the CPI was that it was all trending to budget until, just in the last 2 months, so May, June, it's suddenly gone below 1, which is telling us that there is a cost performance problem that's been occurring just in the May, June period. Whereas the schedule performance seems to be quite up and down, having started being very positive, or more work being completed than planned. It's dived down below and has just recently dipped up in the June month, showing that the amount of work that's being performed seems to be greater than the amount of work that was planned. This is another representation that's not used so much, so I haven't seen this used so much in practice, but it's another representation of putting CPI and SPI on the same matrix. And by putting a data point there, you can see that the idea being that if your project is appearing in the top right-hand quadrant, it means it's performing at a high SPI and a high CPI, so that's the ideal situation, and progressively working down towards the lower left quadrant, where if there were projects appearing in that quadrant, it would be an indicator that they're performing poorly from a cost and schedule perspective. So it just gives you, if you have a program or a portfolio of projects, it's a way of representing how different projects are performing relative to each other, or how different WBS elements within one project might be performing. So the variance analysis and reporting summary, we've looked at a number of different analysis techniques, variance analysis and contract performance reports. So CPRs being the more detailed breakdown of cost, schedule, performance reporting for current period and cumulative to date. The next section to have a look at is subcontract management. So everything that we've been talking about so far is quite easy to manage if you're doing it internally. You have a lot of control. But when it comes to subcontract management, the reporting requirements really need to be written into and baked into the subcontract and need to be documented. So this is one of the reasons why it's really important to have project controls people involved in the procurement phase of a project, so that they can help ensure that the right reporting requirements are being written into the specification. The reporting requirements should be chosen to vary with the level of risk. So if there's a high level of performance risk and you're concerned about performance for some particular reason, it might be a critical package of work, then it's really worthwhile to make sure that those earned value requirements are written into the contract. Whereas if it's a lower risk package of work, it may not be necessary, and it might just be more of a transactional nature. So major subcontracts are normally identified in the proposal stage and require an increased level of surveillance and reporting because of the size and nature of the work or the services being procured. And EVM reporting may flow down contractually to a major subcontractor, whereas some of the simpler vendors, earned value reporting requirements may not be necessary. An integrated baseline review may be required. So we spoke about an integrated baseline review earlier. I guess the standard type of IBR typically happens within 6 months or within a couple of periods of setting a new baseline. Another option is to collaborate with the subcontractor up front before the initial baseline is set, which helps bake in quality and good decision making into the original plan, rather than having to catch things after the horse is already bolted through an IBR process. The IBR verifies the credibility of the subcontractor's management and control systems and plans, and also ensures a shared understanding of the risks in the subcontractor's management control systems, and it develops a plan to help reduce such risks. So the variance analysis and reporting summary, it's important to review and understand that cost-effective, accurate, timely and properly controlled baseline changes are occurring at the appropriate levels within the project. Ensuring that all budget revisions are reconcilable and traceable back to the authorised budget within the control account budgets. We really need to prevent modifications to the baseline unless it's authorised through the change control process that formally documents all the approved baseline changes. So the change control process should really be protecting the project from unauthorised scope, so it's the gatekeeper And the changes that come through should really be like a mini business case, and the change control process makes sure that the right changes are being flowed through. And so that summarises and really completes the analysis of management reports modules. So you should find that there's a number of different sample questions that you can go through in your study guide. So I definitely recommend going through those suggested questions, seeing how you go with those. And if you have any challenges or questions with those, don't hesitate to get in contact with me. Thank you very much.